While test codes are usually generated by the supercalculate buttons, you can write user codes, which means you can declare your own variables or calculate secondary variables in the I/O panel of a solution. The test code coupled with user codes create a powerful combination for parametric studies and simplifying the solution procedure. Let's have a few examples. I'm in the system evaluation page, system state, SL model, and the first example, if you click on the test codes, you will notice that over here we are calculating secondary variables, the change in kinetic energy, change in potential energy in this problem. Obviously, they are not part of the regular properties of a state, but you can calculate secondary variables like this. Only caveat is that on the right hand side there must be variables that has been already declared, or state properties, standard state properties such as E1, E2, val1, val2, etc. You cannot use a state property on the left hand side. You cannot, for instance, T1 means temperature of state 1, so you cannot declare T1 equals 500 in the I/O panel. Just to show you a little more use of user codes, look at these codes. Here we are trying to find the efficiency of the turbine, which is not a variable, standard variable. So this is where it's calculated, W.external2 by W.external1. One more example. Here you can see that the pressure ratio is given as 12. This is a Brayton cycle problem. So actually, let's go and regenerate, and we can see the use of user code right now. So if I go to the app, I/O panel, we load the solution. So you notice that all these variables P1, T1, V1, these are standard variables. So in the I/O panel, we cannot declare those as user variables. So to isolate the user codes, you can click this button, show user codes. You can see that P ratio is 12, T max is 1500, and vol dot is 10 as declared. Notice that the T can be a valid variable, but T1 cannot be, because T1 means temperature of state 1. And all these numbers should be in SI units, so it must be T max must be in Kelvin, and of course P ratio is the pressure ratio, vol dot must be in meter cube per second. If we go to the solution, for instance, the thermal efficiency in this particular case has been found to be 50.86%. Look how easy it is to do a parametric study. If you say, suppose the pressure ratio is not 12 but 15. We just calculate here to register the change. So you see your P ratio is now 15. And the problem has been set up in such a manner that, look, P ratio appears here. The number 12 doesn't appear anywhere. So all you need to do is to click the super calculate button. Yeah, all the panels are updated. We can go to the cycle panel and see the effects on the efficiency. Thermal efficiency is now 53.9%. So as you go through examples on hands-on example page, you'll find test codes everywhere. And if you open up the test codes, you'll see at the bottom all the user codes are isolated at the bottom, and you can read through it to understand the special feature of this, how we isolate important variables through user variables.